Okay, Assalamualaikum and greetings to everyone. My group and I will present our group building project. Okay, this is our group members. Syafisari, that's me. My friend Muhammad Ishak, Muhammad Sharashdan and Muhammad Amin.
I want to talk about introduction. We know that C programming is a widely used and influential in language for computer system and application. So for C programming, compiling it into executable file and running the program. So C uses function, data types, control structure, pointer and structure. For selected machine specification, we chose a lathe machine. So for lathe machine is a versatile tool used in industries like metalworking, woodworking and manufacturing. A lathe machine comes in different size for small to large and are essential in creating various products like engine parts. The turning process involves shaping to the outer or inner surface. And lastly, facing is another aspect of turning where the cutting tool moves across the end. Second, for drilling machine. So for drilling machine, creates cylindrical holes using drill bits, using presses and lathes. And then drill bits may cause slightly larger or undersized holes. Third, drill bits use fluting to remove chips with specific materials requiring specific speeds and feed rates. And lastly, boring machinery include reaming, achieve a polished finish and precise hole sizing using machines. And lastly, we choose a milling machine. Milling machine operation includes milling and face milling. Milling involves rotating cutters, removing material using fixed table and tools. And lastly, milling machine are versatile, capable of planing, cutting, rotating, and have four main type: hand, plane, universal, and omniversal. For operational analysis, lead machine, the main part of lead machine is chuck, headstop, compound rest, cross slide, and tail stop. Operational analysis drilling machine, we have many part. So the main part of drilling machine basically is electric motor, column, base, arm, and spindle. For operation analysis milling machine, we have a main part of milling machine. So we have a motor, head, spindle, vertical position screw, and table power feed. For a specification of machine, lathe machine have a capacity and bed. For capacity, have a height of center, swing over bed, swing over cross slide, movement of cross slide, swing in gaps. For bed, we have bed type, bed width, length of gap in bed, length in gap in front of free plate.
Okay, for specification of machine latte, machine have many types, which is main spindle. The main spindle have a size of thread spindle nose, taper bro spindle sleeve, spindle bro, spindle pulley, spindle bearing front, spindle bearing rear. F. And for type of tail stalk, have a spindle diameter, taper bow in spindle, and spindle travel. Okay, so compile slide have a travel of compound, slide, tool shank section, swelling degree. And next for the speed, have a number of speed and range, which is RPM. Okay, for the next one is street or number of range, which is lead, screw diameter and pitch, metric and inch. Okay, for the electrical, main motor 1440 RPM and motor with V belt. Yeah. Okay, for specification of machine, I have two type, which is milling machine and drilling machine. For milling machine, I have parameters and value. Parameters have power, diameter of cutter, number of teeth, material of cutter, young modulus, spindle speed, range, feed rate changes, specific cutting energy, size of workpiece, width of depth of cut. And for the drilling machine, drilling capacity, spindle nose, spindle travel, center of spindle to columns, number of spindle speed range, column diameter, drilling motor, and range of power feed.
Okay, this is a flowchart for lathe machine. To know the steel material type for FPM and to get the diameter. Continue for lathe machine chart. This chart is to get a metric measurement print spindle speed. Okay, this is a flowchart for milling machine. To know the total part machine time and product waste generated, productivity per day, material efficiency, and the lastly is total energy consumption. Okay, this is a flowchart for drilling machine. To get the average speed total and display average speed, higher, lower, or equal.
Okay, this is our codes for lathe machine. As you know, there are many language for coding, but we are using C language for our coding. Okay, this is our output for metric measurement for lathe machine, and this is program output for US measurement for lathe machine. Yeah, this is our program code for milling machine. Okay, this is our output for milling machine program codes. Okay, this is our codes for drilling machine. Okay, this is output for drilling machine code.
Okay, for this calculation, use a metric measurement and the value already given in the table. So just use the right value for material to find the material steel type 1010, for material steel type 1140, material steel type 1117, and the last one material steel type 1212. Okay, this is calculation for latte machine. Use the US measurement. The value already given in the table. So for material steel type 1010, 6.2 over pi equal to 1.97. For the spindle speed, 12 times 90 over pi times 1.97 equal to 174.50 rpm. Okay, for material steel types 1140, 6.0 over pi equal to 1.90. And for the spindle speed, use 12 times 50 over pi times 1.40 equal to 100 rpm. Okay, so for material steel type 1170, which is 5.5 over pi equal to 1.75, and the spindle speed 12 times 120 over pi times 1.75 equal to 261.92 rpm. Okay, for the material steel type 1212, 6.5 over pi equal to 2.07, and the spindle speed 12 times 160 over pi times 2.07 equal to 295.38 rpm. Okay, this is the calculation for milling machine. They are already given the value of length, width, thickness, radius, distance, and distance h to e. This is the value of y, h, I, j, k, I, and t. So the next step is to find the total of part machine, which product generate, productivity per day, and total energy consumption.
Okay, this is a calculation for drilling machine, and the table is already given. Spindle equal to RPM times D divide 12 times NF. Number first is RPM equal to 800, D is 4, NF equal to 3, and just put it in the formula. The answer is 88.89. Number two is still the step is still the same. Okay, average drilling speed is 88.89 plus 66.67 plus 53 plus 33 divided by 3. So the answer is 69.63. Okay, lastly is the conclusion. Milling, drilling, and lathe machine are essential in various industries, especially engineering. Coding enhance their efficiency, user friendliness, safety, and time-saving capabilities. Computer programming offers financial rewards and intellectual fulfillment. Programmers must possess an appetite for learning and solving complex problems, recognizing that no program is flawless. Mistakes are inevitable, but they serve as valuable learning experiences. Engaging in exercise in refined coding abilities and leads to mastery in this domain. That's all. Thank you.